Hey class, we are going to talk about quadratic functions today, which is found in section 2.1. Our objectives are to analyze graphs of quadratic functions, to write quadratic functions in standard form, and use the results to sketch graphs of functions, and to use quadratic functions to model and solve real-world problems. So a little bit of vocabulary. So polynomial functions are classified by degree. For example, f of x equals a, where a does not equal 0, has a degree of 0, and is called a constant function. The polynomial function of f of x equals mx plus b, where m does not equal 0, has a degree of 1, is called a linear function. We know that to be slope-intercept form, by the way. The next one says the polynomial function of f of x equals ax squared plus b. That should say bx. So let me fix that, sorry. That should say bx plus c is called a quadratic function, and that's written in standard form. And its graph forms a U-shaped curve called a parabola. Just a little bit more vocabulary. It says all parabolas are symmetric with respect to a line called the axis of symmetry. So the point where the axis intersects the parabola is called the vertex. Okay, so if you look on these two graphs, one is opening upward, one is opening downward. What you'll notice is a dashed red line, and that's going to be considered your axis of symmetry because it cuts your vertex in half. And then the lowest point or the highest point is called the vertex. A little more vocabulary. So the simplest type of quadratic function is f of x equals ax squared, whose vertex is 0, 0. So that's the parent quadratic function. Remember, if a is greater than 0, the graph opens upward, and the vertex is the minimum. So let me write a couple of things. I mentioned that this one was the parent. Okay. And then if it opens upward like that, I kind of missed my origin, but it's okay. Then this point here is called our minimum. Okay. If a is less than 0, and again, this is when a is greater than 0. So when a is less than 0, it opens downward. Again, very terrible parabolas here, sorry. But that is going to then be called our maximum point. Then our vertex is a maximum rather than a minimum. And then it lets us know if a is greater than 1, then the vertex will stretch, or the graph will stretch. So if this is a regular parabola, a stretch, it's like stretching up towards the sky. So it stretches your function. And if it's between 0 and 1, usually for us, it'll be like a fraction or some sort. Then it'll be vertical compression or stretch. So that means it's kind of wide. Okay. So we're going to practice. So it says, describe how the graph of each function is related to y equals x squared. Well, first of all, remember we're comparing it to y equals ax squared. So we're looking specifically at the number that comes in front of the x. And based off of that, I see on this first one that it's 1/3, and on the second one it's 2. Based on the fact that 1/3 is less than 1, but it's also less than 0, that makes this graph compressed. So I would say that it has been compressed by a factor of 1/3. Okay, and then on the second one, because 2 is greater than 1, then I know it's stretched, so I would say it has been stretched by a factor of 2. And again, these are just saying describe how the graph has been transformed rather than graphing it. But if you did want to see your graph on your graphing calculator, the best way to do this is to make y1 equal your x squared, and this one could be your y2. And if you clear out that as your y2, then again, the next comparison could make that your y2. So just so you know. All right, so again, we're trying. So we're using what we know plus other transformations that we have discussed so far this semester. So as a reminder, if your number in front of your x is negative, that means it reflects across the x-axis. And then remember, the +1 means that moves up 1 unit. So that's how that one has been transformed. Okay, and I should make a complete sentence out of it. So I would say that it has been reflected across the x-axis and shifted up 1 unit. The second one, this +2, remember, if it's inside of your parentheses, it's opposite of what you think. So instead of it going to the right 2, it has been shifted left 2 units. And remember, the -3 means down 3 units. Okay, that's it. And again, if you want proof, you can look at these on your graphing calculator. All right, so the vertex form. So it says f of x equals a times the quantity of x minus h squared plus k, whose axis of symmetry is the vertical line x equals h, and vertex at the point hk. So in other words, we've practiced the details of A. Remember, A will give you stretch, it will give you compression, and it will also give you reflection. Please forgive my stylus, it's just pretty bad. All right, so that's what A does. And then as a reminder, H is left and right, but it's opposite of what we think. So it's left and right, but it's opposite. And then the last one, K is just up and down. And by the way, your HK comes from the position of left and right and up and down, which makes sense because to get to a point on a graph, we would usually go left and right first, and then we would go up and down to get to a point. Okay, just as an example. All right, so here we are going to identify the vertex of the quadratic function. So it says describe the graph of f of x equals 2x squared plus 8x plus 7, and then identify the vertex. All right, so let's begin. So first of all, the vertex from the other screen tells us that vertex is in the form of hk. But momentarily, I just want you to think about it as xy for what we're about to do. So to begin to find the vertex, you have to know that x equals negative b over 2a. And then you're probably like, well, where does a and b and all that come from? Well, they are the coefficients. So a is 2, b is 8, and c is 7. So if I sub these values in, I would have negative parentheses 8 over 2 times parentheses 2. So that would give us negative 8 over 4, which gives us negative 2. So x is negative 2. Then obviously to find y, we would substitute that value, negative 2, into our original function. So that would be 2 times negative 2 squared, okay, plus, that's a negative by the way, plus 8 times negative 2, and then plus 7, all right? If you do order of operations, that actually is going to mean that this negative 2 squared is going to take place first. So negative 2 squared is actually 4, and then 4 times 2 is 8. And then the next portion we have right here says 8 times negative 2, so that's negative 16, so minus 16, and then plus 7. That's going to give us an answer of negative 1 as our y. So that means that our vertex is negative 2, negative 1. And we got that from what we just did, okay? After that, we will write our function in vertex form. Again, in order for it to be in vertex form, it has to be in the form, and let me switch colors so that we don't get confused. The vertex form is y equals a times x minus h squared plus k, all right? A is your a from here, okay? So for us, this will be y equals 2 times x minus, remember now this is our h and k. It was originally x and y, so I don't want us to get back confused, but going back to it actually being the vertex, it is hk. So this would be minus a negative 2 squared, and then plus k would be plus a negative 1. Now, we don't like to see all these double negatives and a plus negative, so our final answer for the actual equation is y equals 2 times x plus 2 squared, and then minus 1. That's our actual equation. And now to answer as far as a description, well, we can describe the graph now based off of the fact that we can see everything. So what we will say is the graph has been stretched by a factor of 2, and I know that because of the 2 in front. It has shifted left 2 units and down 1 unit. Okay, and that's all we needed to know. All right, in example 3, we are asked to describe the function again, but this time we're going to identify some x-intercepts. So in order to identify, again, we want to get it into vertex form so that we can see all the transformations that have taken place. And then to find x-intercepts, that is where we actually begin to factor and solve for our x value. Okay, so to do this by hand, first thing that we want to do is, again, x equals, to find our vertex, negative b over 2a. All right, so that would be negative parentheses 6 over 2 times negative 1. Again, that's because this is our a. A is negative 1, b is 6, and c is negative 8. All right, that will give us negative 6 over negative 2, which gives us 3 as the first part of our vertex. Then for y, we're going to substitute 3 into our function. So that'd be negative parentheses 3 squared plus 6 times 3 minus 8. If we keep going, that will give us negative 9 plus 18 minus 8. So that was really 9 minus 8, which is 1. So our vertex will be 3, 1. Perfect. Now to write it in vertex form, remember we're going to use y equals a times x minus h squared plus k. So that's y equals a is actually negative 1, so I'm just going to put a negative parentheses x minus h is 3 squared plus k would be plus 1. So that is our function. And then our description will be, I'm going to use shorthand even though you should use a full sentence. I'm going to say that's been reflected across the x-axis. It is shifted right 3 units and up 1 unit. Okay, again, I use shorthand. You should use complete sentences. All right, and then the second half of the problem says identify any x-intercepts. So to do x-intercepts, that means you are setting your function equal to 0. So that would be negative x squared plus 6x minus 8 equal to 0. I do something called the AC method, which means I'm going to multiply my a and my c together and then figure out what factors will give me my center b term, which for us b is 6. So negative 1 times negative 8 gives us positive 8, and then I'm going to list my factors of 8. So it's 1 and 8 or 2 and 4. Now, of these two options, the only ones that can possibly give me 6x are 2 and 4. So then I'll begin to rewrite. Well, we'll keep going. So this will give us negative x squared plus 2x plus 4x minus 8 equals 0. Okay, I grouped the first two and the last two. If I factor out a negative x, I am left with x plus 2 or x minus 2, sorry. Okay, if I factor out a 4, I'm left with x minus 2. The goal is that both of your parentheses are the same so that I can continue to factor. So that would leave us with, in parentheses, negative x plus 4, and then x minus 2 equal to 0. All right. From here, what I should technically do is your x's should technically really, they should really be already, well, I guess it won't make much of a difference. So let me just keep going. So then we set each of those equal to 0. So negative x plus 4 equal to 0. That means I would subtract 4. Now we get negative x equals negative 4, so x equals 4. And as the other one, I would have x minus 2 equal to 0, add 2. So I get x equals 2. And remember that these are x-intercepts, so as an ordered pair, they represent 4, 0, and the ordered pair 2, 0. In other words, this is where our graphs are crossing the x-axis. And that's it. All right, to continue, it says find the vertex form of the equation for the parabola that has its vertex at 1, 2 and passes through the point negative or positive 3, negative 6. So again, we're going to go back to our vertex form, which states that y equals a times x minus h squared plus k. Okay, and then from there, we're going to identify a couple of pieces of information. If they're telling you that this just represents any old point, then this represents x and y. However, whenever they use the vertex, they actually mean h and k. So for us, all we're doing is we're going to substitute these values into our equation, our vertex form equation, and then the goal is to find a so that we can do a standard version. And when we write our standard version, we just want the a, the h, and the k as usual. Okay, so our y is negative 6. Equal to a is we don't know. Parentheses x is 3. Minus h is 1. Squared plus k is 2. All right, I hope all the colors are coordinating and that we can see what's going on. So if I take the center part 3 minus 1, that gives you 2. So negative 6 equals a times 2 squared plus 2. 2 squared is 4. So that's 4a plus 2. Subtract 2. I get negative 8 equals 4a. And then I'm going to divide by 4. So a equals negative 2. So when we write our final function or our vertex form of our equation, we will get y equals, remember, all we need is a, h, and k. So our a is negative 2, parentheses, x minus h, so it's minus 1 squared, plus k is plus 2. So that is our equation written in vertex form. All right, so now we get on to some word problems. It says a baseball is hit 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to ground level. The path of the baseball is given by the function f of x equals negative 0.0032x squared plus x plus 3, where f of x is the height of the ball in feet. What is the maximum height reached by the ball? Okay, so for us, what that will mean is if we want to know the max height of the path of a ball, first let me draw something. The max height, understand that this represents distance, specifically in feet, and this will represent height. This is height. Okay, if this represents height and they want to know what's the max height reached, they want to technically know this level here. Specifically, what is that point there? And we know that this is our vertex. And specifically, if we're typing this into our calculator, that would be our maximum. Okay, so I'm going to do it by hand first. and then I'm going to do it by calculator. So to find the maximum by height, remember height represents the y value. Height represents the y of our ordered pair xy. So that means I'm going to have to find x first, which remember that's x equals negative b over 2a. So I use the a, b, and c from here. So that's negative 1 over 2 times negative 0.0032. That will give you about 156.25. Remember, that's feet. So at 156.25, that is your max height, but that's not what they're asking for. They're asking for the maximum height. So then we would say y equals negative 0.0032 times 156.25 squared plus 156.25 plus 3. If you type that all into your calculator as a final answer, you'll get 81.25 feet. So the ball reaches a height of 81.25 feet. Now to do this on your calculator, you will, first of all, your window is going to have to be completely increased by a lot. So I would make our window like negative 100, positive 100. So I'm doing that on my calculator. And then I would type in that function. So negative 0.0032 x squared plus x and then plus 3. So if I graph that, hopefully I should see my maximum. But what I notice is if I change my my window to negative 100, positive 100, it doesn't work. And that makes sense because what we found as our max height is 81.25. So really we need to kind of double that so that we can see the entire thing. So my window on my x min and max, I'm going to make my x min 0, but I'm going to make my x max 200. And with a window such as that, I am able to see my maximum. So I'm going to say second trace, go down to number 4, which is maximum. I'm going to move my cursor somewhere on the left, and I'm going to move it somewhere on the right of what I would assume is my maximum. I'm going to press enter, then it asks for me to guess. So I'm going to press enter again. And it tells me exactly what we did by hand, which is x equals 156.25 feet, but that's not what we want. But the y, which is the maximum height, is 81.125. It is actually what I got instead of 25. Oh, I just wrote it wrong. It says 81.125. Sorry. Alrighty, let's look at the last example. All right, so it says, according to a survey, the percent of income that Americans give to charities is related to their household income. For families with an annual income of $100,000 or less, the percent is approximately P equals that equation, where P is the percent of annual income given and X is the annual income in thousands of dollars between 5 and 100. According to this model, what income level corresponds to the minimum percent of charitable contributions? So to find the minimum percent, first of all, when they ask for the income level corresponds to X, which is the annual income. So if we're talking about the income level, and then it's asking what percent, meaning the minimum percent, again, this question is asking, well, hey, find what your minimum value is if we were to find the vertex of this parabola. So for us, again, X equals negative B over 2A. Negative B would be negative 0 or negative 0.1529 over 2 times 0.0014. Okay, that will give you about 54.6, which equates to about 54,600 as the minimum income level. Okay. Again, though, if we wanted to put this in our calculators, we would type this in. You would do your second trace min, and specifically you were looking for the X value. And again, you should get about 54.6 in your calculator. So guys, we are done. If you have any questions, please be sure to come see me for tutoring.